Okay. So trig unit, probably one of the easiest units, I guess, in my opinion, that we looked at. So we start off by just reviewing Pythagorean's theorem from grade 9. And so you should know this one pretty good, so I'll go through it pretty quickly. Remember, when you're dealing with Pythagorean's theorem, and you're not actually given Pythagorean's theorem on the formula sheet, so you have to memorize it. This a squared plus b squared equals c squared. This is the formula if it's set up to solve for a hypotenuse, or you can manipulate it to solve for a missing leg if you want. So remember, this here, side C is the hypotenuse, and side A and B are what we call like legs of that right angle triangle. And so you can either rearrange that formula, or I can remember my other formula, which is a squared equals c squared minus b squared, or whatever combination of those variables, to solve for a missing leg. I'm going to make the assumption that everybody's good with Pythag, and we could identify when to use Pythagorean's theorem. Yeah. So in order to use Pythagorean's theorem, you have to have two other side lengths. So sometimes like you'll run into a question maybe on the quiz or on the review or in a practice test where you're given two side lengths, and because you're in like the trig mode, you'll think, oh, I have to use either SOHCAHTOA or TOA. But remember, you can always still use Pythagorean's theorem to solve. Another just basic rule that we kind of review from other grades is that all of the angles of a triangle always add up to what? 180 degrees, right? So essentially, all of the triangles, whether it's a right angle triangle, it's obtuse, it's acute, whatever type of triangle it is, all of those angles will always add to 180. But because we are generally dealing with these 90-degree triangles, that means these other two angles will always have to add up to 90 degrees as well, right? So you can kind of look at that either way. Okay, so the one thing to remember for the trig unit is as soon as you go into the gym to write your test, they're going to clear your calculator, right? So if I clear this calculator right now, so if I go second, memory, reset. All right, so that's what you're going to see, like whenever your teacher or whoever ends up clearing your calculator for you when you go walk into the gym, this is what you're going to come up with. And so what you need to do is you need to go, before you solve any questions on the test, is change your mode back to degree. So what you're going to do is hit this mode button right here, and this is what it's going to look like, because every calculator is going to look the same because it just got reset. And so then you'll need to scroll down, and you want to highlight degree in black. So I'll go over and I have to hit enter on it. And now that means my mode is in degree. So make sure you do that. Otherwise, every single question for the trig unit is going to be wrong. Okay, so really make sure that you pay attention. The newer calculators tell you, like at the very top right here, that that's in degree. The older ones don't tell you that. So just make sure that you're confident that it's in degree mode before you try and go solve any questions. And so remember, you're going to go check mode, and then you want that highlighted in degree. Oh, that's a B, degree. Okay, make sure you do that. All right. Next part, talking about trig, is then we have to remember how to label the sides of a triangle. If you don't appropriately label the sides of a triangle, there's no way you're going to get any of the trig questions right. And so generally what we start off with labeling the sides is, I always say label the hypotenuse first. That's the easiest one to start labeling. So we always label H, or the hypotenuse, first. So this is kind of like the ordering label. I can't think of the word. The order, I guess I'll say, in which I label the side. So hypotenuse. Now hypotenuse, before we come in here, we say, oh, the hypotenuse is the longest side. But if you don't have numbers, or you think, oh, unless I get out my ruler, I can't tell which side is the longest. So I always just say, whatever side is diagonally across from the right angle, that's going to be my hypotenuse. So this is the side across from that 90-degree angle. That says 4 from 90 degrees. Okay. The next one is the opposite. Now, the opposite can change depending on where my angle is. So right now, theta is right here. Theta is either like my angle of interest, or it's the given angle in the question. And that's how I will label the rest of my question with respect to that angle. So if here is theta, to label the side opposite, I'm literally just looking for the side opposite of that angle. So we call that the side across from that angle. From the, angle of interest. The last side then, so this is H, I guess I should say, so opposite 90, hypotenuse, opposite the angle of interest, opposite, and the remaining side then is what we call the adjacent side. And I just say that's the remaining side. So I'll label that as A. It doesn't, like, there's kind of another definition. Oh, it's the other side that touches your angle that's not the hypotenuse. That's your other definition for adjacent. But if you go through it in this order, where I label my hypotenuse, then I label my opposite, the side that's remaining is then going to be the adjacent. All right, so on the test, what you're going to be given is this. You're just going to be given this little mnemonic thing to remember. So, ka, toa. That's all you're given. You need to be able to create the trig ratios given that mnemonic device. And so sometimes I like to, rather than writing it like that, I'd write it like this. So, ka and toa. Just because that kind of gives me an idea as to how the formula is going to be created. And so if you remember, so is equal to sin or sine of theta is equal to O over H. So that's how we create that formula. Sine theta is equal to the opposite over the hypotenuse. Cos ka is the cos then, which is equal to what? Cos theta is equal to ka, which would be what? Adjacent over hypotenuse. So adjacent over hypotenuse, or A over H. Generally, I don't really say the full word, but it's there. So A over H. And TOA is tan of theta equals O over A. And so you need to be able to create those three formulas given the mnemonic device. And if I write it like this, like O over H, A ka is A over H, and tan is O over A. So you have to be able to produce those formulas for yourself. Good. Any questions? So far, so good. Kind of remember everything? Yeah. Okay. All right. All right. So really, there's only two sorts of things we can do to solve in this unit. And either we're looking for the missing length of a triangle, or we're looking for the missing angle of a triangle. And so I'll look at solving for a missing side length first of all. So if I'm trying to solve for a missing side length of a right angle triangle, given two sides, if I'm given two sides, so let's say I had this triangle, I'm given this is 4 and this is 7. Well, what's that side? I should be able to identify. If I have two side lengths, I'm looking for a third. I'm going to use Pythagorean's theorem. And I won't write that down again. I hope that everybody knows it. So the other type of question that might be asked is if I'm given a side length and I'm given an angle, I'm going to use one of my trig ratios. So that would be like a triangle like this, where I say, okay, this is 40 degrees, this is 7, what's x? So I'm given a side length, I'm given an angle, now I have to go find the length of the missing side. And so I'll use a trig ratio to help me solve that. Kind of just some brief steps to solve then if you're given this scenario is first, if you're not given the diagram, create it on your own. Unless you're really good at like picturing things mentally, which I personally am not, I always just at least create a little sketch for myself and fill in the numbers from there. Then you have to determine, then you're going to, label your sides. Right? Label H, the hypotenuse, label the opposite, and then label the adjacent. You have to label your three sides, and generally in that order makes your life a little bit easier. Then I'm going to determine which trig ratio to use. So depending on the information that I'm given and the information I'm looking for, I'll decide, am I going to use so, ka, or toa, and then I'll substitute the numbers into that formula. From there, remember, you're going to use cross multiplication, then divide. And so if you're cross multiplying, remember you cross multiply the numbers that are diagonally across from each other, divide by that number that you haven't used yet. So let's go look at an example. And this is the harder example. So maybe I'll do an easier example first. Right, that's a harder one. So let's say I'm given this triangle. Ooh, that's bad. Okay, so here is 7. Here's theta. Oh, sorry. This is 70 degrees. I want to know what the length of x is. So I'll do this one first. So I'm given a side length. I'm given an angle. That means I'm going to have to use one of my trig ratios to solve. So to solve, the first thing I need to do, then I'm going to have to start labeling my sides. So the side across from my 90 degrees is the hypotenuse. The side across from this angle of interest is the opposite. And the remaining side that I haven't yet labeled is the adjacent. So now I need to figure out, once I've labeled my sides, what trig ratio am I going to use? Well, there's a A here and an I have A and I'm looking for O. So I'm going to use TOA because I have O, or I'm looking for O and I have A. So in this formula, tan theta equals O over A, I'm going to substitute the information from the question into that formula. So I would have tan of 70 degrees equals the opposite, which is what I'm looking for, x, over A, which is 7. I generally like to use like x rather than 0 in here, right here, just because otherwise sometimes people get mixed up and they don't realize that's an O or think it's a 0. So if I'm going to cross multiply here, what I would need to do is recognize that technically tan of 70 can be written as a fraction over 1, because I sort of have a proportional relationship here between these trig ratios. So tan of 70 over 1 equals x over 7. So if I'm going to solve here, I'm going to solve for x by cross multiplying and dividing. So tan 70 times 7 over 1. So tan 70 times 7 over 1. Now, dividing by 1 in that example really does nothing, but it's good to get in the habit of setting that up, especially for questions like this one that we're going to go look at, where you need to have that over 1 to solve. So if I'm typing that in on my calculator, so if I go back to my calculator here, sorry, to type that in, so tan of 70, make sure you close that bracket. You have to go tan 70 bracket of that angle, right? Then I'll take that and times it by 7. So that side length is 19.2, whatever my units are. If I did it the other way, where I didn't close that, my answer is just not going to make any sense usually. So tan 70 times 7, negative 1.1. Well, that's impossible, right? So make sure that you're closing off. Sometimes it might be reasonable, but sometimes it won't be. So make sure you're closing off your angle when you're solving those questions. So we just said that was, equal to 19.2. And my work for that's done. Sort of remember that? Yeah? Think you can do the second one on your own? Yeah? Okay, so if you're watching, pause the video and try this triangle on your own. If you're sitting here, try that on your own. Can I pause this? Assuming that's good. Okay. All right. So this question is a little bit harder, and especially depending on like the way you write stuff, might be hard to see what you have to do. So I'll label. So directly across from the 90 degrees, that's the hypotenuse. Across from that angle of interest, or that given angle, is going to be the opposite, and the remaining side is the adjacent. So I have A, and I'm looking for H, so I'm going to use Ka. And so at least you guys were able to set up cos theta is equal to A over H, and you took the numbers, substituted into here. So cos of 30 degrees is equal to A, which is 7, over H, which is X. And then we're kind of like, how do I solve for here? And I sometimes find a problem if people do this, 7 over 8. It doesn't really want to work out as well. So if I put this as 7 over X, And like I said before, we want to set up a proportion here. So I'll set this up as cos 30 is technically over the invisible number of 1. Now, if I set it up like that, I should be able to see that my two numbers that are diagonally across from each other here are 7 times 1. So to solve for x, I go 7 times 1 and divide by that number that I haven't touched yet, which is cos of 30 degrees. So that's where it comes into play that it's important to set up that invisible one where you can cross multiply. I could technically times x to either side and then divide by cos 30. That would work as well. But so then on my calculator, I'm going to go 7 times 1, which is just 7, divided by cos of 30. Whether you close the bracket there or not wouldn't matter. And so your answer is going to be approximately 8.1. Does that make sense? Oh, okay. You guys are okay? Remember that now, sort of? Yeah. So that's where it comes into play, where you have to set that up over 1. And obviously, you could also use sine depending on what you're given, but in the two examples we have here, we're not given that. All right, next part. So the other thing that we're looking at is, now I've looked at to solve for a missing leg. Now we'll look at to solve for a missing angle. Either you're given enough information to figure out the other angles by like subtracting them from 180 degrees. Or what I need to do is figure it out using some sort of trig ratio. So just kind of some basic steps here. If you're solving for a missing angle, if you are not given a diagram, create one yourself. And then you have to label the sides H, O, and A with respect to the angle of interest or whatever angle you might be looking for in that particular question. Then we need to determine which trig ratio to use, same as before. So am I using SO, am I using Ka, or am I using TOA? Remember, when you're trying to find an angle, then you need to use the reciprocal trig ratio. Reciprocal trig ratio. And the reciprocal trig ratio is like sine -1, cos -1, and tan of -1. And it's called the reciprocal because that goes back to our exponent laws. And so you're always using that reciprocal or that -1, that second of the trig function. So -1 if you're trying to find a missing angle. So we'll take a look at this example. So find the indicated angle and round to the nearest tenth. So first few steps are going to be exactly the same, right? I label my sides. So here's the 90-degree angle. So the side across from there is going to be the hypotenuse. Here's my angle of interest. So the side opposite or across from that is labeled O for the opposite, and the remaining side is the adjacent. These ones are usually a little bit easier to define what trig ratio you're going to use because I have O and I have H. So I have O and H. I'm using SO. So then I would go sine theta equals O over H, and I'll take the information I'm given and substitute into that formula. So sine of theta equals the opposite, which is 3.5 in this question, over the hypotenuse, which is 8.7 for here. Now, to solve for theta, essentially what we're doing is dividing by sine to either side, which gets sine to the denominator. So I have sine to the -1. But if you just realize, well, I'm trying to solve for the angle here. To solve for theta, I need to go sine -1 of whatever this ratio is of 3.5 over 8.7. So I'll use the reciprocal trig ratio of whatever fraction I have set up, and I can just type that in on my calculator. So on my calculator, I hit the second function and of sine, and so that gives me the -1 right there, which indicates that I'm trying to solve for the ratio, and it's 3.5 over 8.7. Oops. Delete that. 8.7. Whether I close the bracket there or not, it shouldn't really matter. And so that angle is 23.7 degrees. So theta is equal to 23.7 degrees. All right, so yeah, the big thing there is just remember to find that missing, or use the reciprocal trig ratio. Any questions for that? Sort of remember? Okay. Just 2 or 3 more things. So the word problem. So trig is used in a lot of real life, and we talked about kind of some common applications of it. So what are the angles of elevation or angles of depression? And so sometimes you look at word problems and they'll give you this information. I call it the angle of elevation, but some people also call it the angle of inclination. So when you look up the angle of inclination or elevation, is formed between the horizontal up. So if the horizontal is my line of sight, so right here is my line of sight, the horizontal up to looking at this plane, that would be called my angle of elevation. So an angle horizontal up, that's elevation or inclination. And so then when you go from your line of sight horizontally and down, that is going to be your angle of depression. Right, so horizontal down to that boat in the water then. So horizontal down is your angle of depression. And you kind of have to be really careful in the word problems that you're setting that up right. Sometimes if you're not using that correct reference, horizontal up or horizontal down, your triangle will be created incorrectly, so you won't be able to solve and get the right answer. All right, so here's an example. Sally is 5.1 meters from the base of a tree. So here's Sally. She is 5.1 meters from the base of this tree. Okay, and she's looking at a bird. So there's this bird up here, who is 7.5 meters high in that tree. And so they're like making eye contact. What is the angle of elevation? So the angle of elevation is going to be from the horizontal up. So that's this theta right here. It's not too hard of a one to set up, but just make sure, right? Because I could have said, what's the angle of depression from the bird to Sally? And then I would have to figure that out. And so if I'm looking at the triangle that without all that other additional information, I'm trying to find theta. They give me the height, and this is 5.1. And so given that information, I can see it's a right angle and just start labeling my sides. So here is O, this is H, and that's A. So to find that angle of elevation, what trig ratio would I have to use? Tan, right? I have O and A, so I'm using TOA. So tan of theta equals O over A. So theta is going to equal, I'll just skip a step, tan negative 1 of 7.5 over 5.1. And I'm trying to find an angle, so I have to use that reciprocal trig ratio, tan to the power of negative 1, and divide those two numbers. So if I put that on my calculator, second of the tan, so I get that tan negative 1 of 7.5 divided by, that's times, divided by 5.1, I get 55.8. So 55.8 degrees. Right. One more thing I'm going to look at is just talking about like the more complex trig problems. Complex trig problems are, I guess, sometimes the word problems depending on the way they're set up, and they're also going to be triangles that have like two triangles put together to make one. And so if you have like a complex trig problem, especially if you have two triangles, if you're given two triangles, generally what you want to do is find some dimension of a common side. If given two triangles, find a common side length. All right, so here they give me this triangle, and I'll give you a second to try this one on your own. Let's take I forgot to say that this is also 90 degrees. So if you're given this information here, and I'm asking, what is the length of X? I want you to take a second and see if you can figure that out. So pause the video if you're watching, and I'll give you guys a second here to figure that out. Okay, so let's see. If I go here, so determine the length of X in the diagram below. So what I want to do then, first of all, is I want to find this common side length. So I'm going to call that, I don't know, P. So I'll look at this smaller triangle here. So if this angle is 55, that means this is also going to be 90. So here's H, here's O, and A. So I need to find A, and I'm given O. So the first thing I would do to solve here is use TOA. So tan of theta, which is 55 degrees, equals O, which is 19, over A. And that'll be the first part where people struggle, is to solve for A. So that's technically, or P, I guess, over 1. So to solve for A, I cross multiply and divide. So that adjacent side is 1 times 19 over tan of 55. So 19 divided by tan of 55. So I'll clear that. 19 divided by 10 of 55. And I'm not using that reciprocal trig ratio, right? Because I'm not solving for an angle. So 19 divided by 10 of 55 is going to give me 13.3. So that means this side length, I just figured that out, was 13.3 meters. And now they want me to go figure out X. The problem is, if I look at X here right now, if I'm looking at this triangle, I have this as X. This is 13.3. I know this is 90, but now what? Like, I don't have enough information there. I either need another side length, or I need an angle. How can I figure out either one of those? Yep. Yeah, so we know that this here is 90 degrees, and if this portion of it is 55, this portion right here has to be 35 degrees. Right? That's math. Yeah, my math's good. Sorry. Okay, so then if I put 35 degrees here, I'm going to go solve for X. So I'll label my triangle. This is H. The X would be labeled as the opposite, and here's the adjacent. So once again, I have O. I'm looking for A. I'm going to use TOA. So use tan. So tan of 35 degrees equals O, which is X, over A, which is 13.3. And so if I put that over 1, just to keep that in mind, it makes myself easier when I'm solving for an unknown on the bottom, I'll cross multiply and divide. So X is equal to tan of 35 times 13.3. Divide that by 1, which doesn't do anything in that case, but that's all right. So on my calculator, it's tan of 35. Make sure you close the angle, because I'm not timesing that angle by 13.3. I'm timesing tan of 35 by that. Times that by 13.3. I get 9.3. So X is equal to 9.3 would be the length of that one, that portion of X. Yeah? No? Anybody get that? Okay. All right. So that's the trig unit in a real quick nutshell. Do you guys have any questions? Nothing else? Okay. Monday, review for number unit. Be here.